this video we're going to talk about balanced forces and unbalanced forces. So this is a scrum, okay? In the rugby competitions, you'll see that two groups of people, they're pushing each other, try to push, like say for example, red player try to push the yellow players to the right, okay? Yellow one is going to push the red one to the left, okay? They seems pushing so hard, but most of the time you find that they're not moving an inch, they're not moving at all, okay? Why it happens like that? Because, okay, at that moment they're under a balanced force. So what is a balanced force? Before we talk about that, okay, we have to learn a new technique called free body diagram. So free body diagram, okay, we are describing one object at a time. And then not only this, we are going to show all the forces adding on this object. Okay, so say for example, this example, a man, okay, a man, a lady, I think a man, we're holding a bag, okay. So here is got a man and also got a bag right here. There are two objects. When we draw a free body diagram, we just focus on one object at a time only. So when we talk about the bag, okay, so we have a bag. Not only the bag is not falling down, right? Okay, if no one is holding it, the bag should be falling down. However, this bag, okay, is suspending in the air because we do have a force adding on the bag because I hold it, so therefore a force adding on the bag upward. And this upward, okay, will counteract. We have a non-contact force adding on the back. Everything's on the earth have a non-contact force. That will be the force of gravity. So this force adding upward and force adding downwards. There are two forces adding on the back at this moment. So this one, okay, is called a free body diagram of the back. So we used the diagram, okay, we learned in last video, a loudspeaker floating, okay, over a base. When we look at this, actually there are two objects. One will be the loudspeaker, the other one will be the base. So at this moment, okay, if I want to draw a free body diagram of the loudspeaker, so this is the loudspeaker, okay, we will have a force adding on the loudspeaker because it is on the earth. So therefore, there must have a force adding on loudspeaker, okay, by who pull this loudspeaker downward. It is by the earth. But not only this, okay, we see that the loudspeaker is not falling down. There must have a force pushing the loudspeaker upwards, okay. So therefore, there is a force adding on the loudspeaker. It goes up. Okay, because it's also adding on the loudspeaker, so it have to have the ending of the arrow touching here. So someone will say, oh, is it necessary point right here? Okay, I don't think so. Okay, if you have like pointing here, it's also okay. So as long as the end of the arrow touching the loudspeaker will do, and the directions, okay, must be indicated the direction of the force. So when we have a force adding on loudspeaker, this time is the magnetic force, okay, it will going upward. So this will be the free body diagram of the loudspeaker. So I'll just have one more practice, okay. There is a goalkeeper, okay, stopping the ball, okay, from moving into the net, okay. If we try to draw a free body diagram, should I draw the goalkeeper and the ball? Obviously no, okay. You should only draw one of them. So in this case, maybe we talk about the football. Okay, so the football, okay, actually there is a force adding on the football, okay, that will be because the football is on the earth, so therefore there is a force adding on the football and pointing downward, okay, so we're touching the ball, okay, force adding on football by who? This is gravitational force, so therefore it's by the earth. The ball is moving this direction. Ball is moving this direction. However, do we have a force right there? Do we have a force right here? The answer is no. We don't have a force here. Because why the ball is moving towards the net? Because a few more seconds ago, okay, there is a guy, okay, trying to kick the ball this way. At this moment, force applied. And this force we applied is a contact force. But after the ball leave the feet of the player. Actually, in the middle of the air, the force of the player cannot continue applying on it, except this one is a Jedi. Okay, so you find out, okay, it is not a Jedi, you're not Harry Potter, so therefore you can't exert a non-contact force on the football, even it is in the middle of the air. So actually the ball is flying in the air towards the net, okay, just because of the contact force applied one off, okay, when the player is kicking the ball. Okay, so therefore remember there's no force right there. Okay, this one is very important. But right here, the goalkeeper is applying a contact force on the football. Okay, so the football is trying to move in this direction. Okay, goalkeeper don't want it move this way, so therefore goalkeeper is applying a force opposite to it. So therefore it should have a contact force adding on the ball to this direction. So this is the force adding on the football by the goalkeeper. Okay, so this is the free body diagram or adding of this football. So now I have a look of the effect of the forces on the motions, okay, of an object. Okay, so in the following, I'm going to separate them into 4 cases. Okay, and in each cases, the trolley will have different status. In case 1, we are talking about a trolley at rest, that means not moving at all. And then suddenly, student A and student B apply a force at the same time, okay, on this trolley. And we know that the force by A is equal to the force by B. Because force A towards the left and force B towards to the right, they are the same. So we call this one balanced force. When an object is at rest and there is a balanced force A towards left, B towards right, okay, this balanced force A cancel B. So therefore, the result of these objects, okay, you'll find that the trolley at the end, they will be still at rest. At rest. Okay, so this is case 1. Trolley at rest, you've applied a balanced force. Even you got 2 forces on that, okay. If the force cancel each other, the balanced force, okay, will make the trolley at rest. In case 2, if the trolley right now is moving with a constant speed to the left, the movement of the trolley is in this direction, constant speed, okay? If at this moment, suddenly, I have applied force A and force B right there, and again, force A and force B, they are balanced force, so therefore the force are equal. You will find that, okay, this force, okay, no one is larger than the others. So to the trolley, actually more or less, it can feel nothing, because the forces cancel out each other. So what the trolley will do, they will be continue moving to the left with constant speed. So we'll say that, okay, actually the trolleys are having uniform movement. Okay, uniform movement. Okay, in case 3, trolley is moving constant speed to the left, just like previously. But this time, okay, the force of A and force of B, they are different. Okay, if force of A is force by student A, okay, is larger than the force by student B. So in this case, because A is larger than B, and we will say that this is unbalanced force. When there is an unbalanced force adding on the move of a trolley, okay, it seems that A larger than B. So actually after A cancel B, you still have some towards to the left. If I put it in numbers, it will be easy for you to understand. Force, we use Newton. 10 Newton to the left, 2 Newton to the right. So after they cancel, you have 8 Newton towards to the left. So when the movement of the trolley is moving this direction at the beginning, and you have a sudden push towards to the left, so you will imagine that the trolley will accelerate. Accelerate means speed up, okay? And the direction accelerate should be towards left in this case. Got it? And in case 4, what if the trolley is still moving with constant speed to the left, but this time force A is smaller than force B? Okay, the movement of the trolley is towards this direction. If A, okay, force A is this direction, force B is this direction. Because B is larger than A, say for example this time 10 Newton to the right, 2 Newton to the left. So 10 minus 2, you still have 8 Newton. But this time, okay, it is towards to the right. So if the trolley is moving this direction, moving to this direction, but suddenly there is a force adding, okay, towards to the back, just like you running to the left and people dragging you back to the right. So what happened to you? Can you accelerate? Can you keep the speed? Of course not. So in this case, we will say that, okay, the trolley decelerates. The trolley will decelerate. That means, okay, the speed will decrease, and bit by bit, okay, the trolley will come to a stop. Okay. So these 4 examples, okay, tell you, okay, the effects of balanced force and unbalanced force on the objects, okay, if they're at rest or with a constant speed. Okay, so now have a look one more time. In this case, okay, we got a trolley, okay, and then we have student A, force A to the left, okay, and then B and C. They're adding, B and C are adding on the same direction. So actually, the force towards the right, we just simply add them up will do. So case 1, okay, maybe you can pause the videos and think about, okay, what would be the result. Okay, so case 1, the trolley is at rest at the beginning, and then we have a balanced force. Okay, balanced force means force A equals to force B plus force C. Okay, so if the trolley is at rest, left and right, the balance cancel each other. So the result, the trolley will be at rest. But if the trolley is moving towards the left with constant speed, that means having uniform motion, okay, the force, okay, adding on it, okay, is still a balanced force. So you will see that at that time, okay, they will still have a motion, but that will be a uniform motion. That means moving constant speed, still towards the left. Okay, and then in case 3, if the trolley is moving to the left constantly, and that is unbalanced, A larger than B plus C, A larger than B plus C. So in this case, it seems that, okay, there is a net force towards to the left, net force to the left. If there's a net force towards to the left, you'll find that, okay, the trolley will accelerate towards the left. That means it will move faster and faster towards to the left. And in case 4, moving to the right with constant speed at the beginning, and there is an unbalanced force, A small, B and C large, so it's just like a net force towards to the right. So actually it was dragging the trolley, okay, to slow it down. So it will be decelerate towards the right. So therefore the speed will slow down. Okay, so in short, actually you can see that if it is a balanced force, okay, the object either at rest or uniform motion. But if it is a unbalanced force, it will be accelerating or decelerating. Okay, that will be changing the speed of an object. So in this case, okay, we got a object on a glider here, on an air track right there. At the beginning, if it is at rest, and then we have 2 objects, P and Q, adding a forces towards the left, force P and force Q. You say, Mr. Wong, this one is going down. Okay, why the force, okay, will be towards the left and right? Because we got a pulley here, okay? Pulley can convert, okay, the direction of the force, okay, changing the direction of it. So if force P equals to force Q, okay, we are having a balanced force balanced force acting on the glider. Okay, so if this time the glider at the beginning is at rest and you have a balanced force on it, then you will imagine the glider will not moving because left and right they cancel each other. So at the beginning the distance, it doesn't move, doesn't move, doesn't move, doesn't move, and doesn't move. So the distance time graph, it will be at the same as the x-axis of the time. But if the glider itself, okay, at the beginning is moving to the left, okay, the object itself, okay, is moving to the left, and we still have the balance force. The balance force, they will cancel out Fp and Fq, they will cancel each other. So actually the glider will continue moving to the left, okay, at its own speed. So because it's at its own speed, okay, so you will find that it will be the distance traveled by this will be a straight line, okay, so that one will be a uniform motion. Get it? So to summarize a bit, okay, balance force, okay, we're talking about when a force is cancelled out by another force. This force should have same magnitude, that means same size, same Newton, okay, but in opposite direction. So when it happens, okay, we have a balance force. But balance force, what is the effect of the balance force? It depends on the original status of the object. If it is at rest, okay, they will become stationary. That means not moving. That means at rest. Okay, all this means the same. If the object is moving with constant speed, okay, the object will continue moving with constant speed in the same direction. So we call this one uniform motion. So in short, under balance force, object either at rest or move with uniform motion. But in an unbalanced force, okay, you'll find that, okay, the motion will change. If it is at rest at the beginning, force A larger than force B, okay, the objects will start moving towards this direction. From at rest start to move, okay, the motion change, the speed change, okay. So you'll find that when an unbalanced force acting on an object, normally the speed will change. It can either accelerate or decelerate. So right here, okay, A, okay, if the guy is very strong, have a very strong pushing force towards the right, it is larger than friction, okay, this pushing force is larger than this frictions, okay, then the sofa will move towards the left. But if the friction and also the force, they are the same, and then at this case, okay, the sofa will not move at all. And same as the one, okay, in bungee jump, okay, if the force of gravity is larger than the force acting on the player by the cord, okay, that means the guy right here, okay, have a larger force going down, smaller force right here, the guy will keep falling, okay. But at the lowest part, okay, you see that this is the bridge, okay, the guy is right here, okay, and then try to jump down, okay. So when the guy, okay, all the way to the lowest point, you find that the guy is momentarily at rest and then change direction. So at that point, you will find that force of gravity go down and up, okay, force by the gravity, force by the cord, okay, if they are the same, okay, the guy, the player, will be at rest at that moment, okay. Now come to the exercise, okay. Before you continue these videos, okay, please finish it first, okay, finish it first, okay. So the first question is, no force can act on an object that is not in contact with any other objects. That means we got a basketball here in the middle of the air, okay, in the middle of the air. There is not allowed to have any force acting on it, of course not, okay. The earth, okay, won't care about that, okay. You have a force acting on the ball by the earth all the time. That is a non-contact force. So this one is wrong. Okay, B, a non-contact force must be a pushing force. Okay, right here it's not. Okay, this is not a pushing force. What is this? It is a pulling force. Okay, pull the basketball towards the earth. So therefore this is wrong again. Okay, magnetic force, okay, can be a pushing or pulling. Say for example, you got a N side of the magnet, you got a N side of the magnet right here, then this one will be pushing away. But if you have N side of the magnet, you put a south side of the magnet, you will be pulling towards it. So therefore, non-kinetic force can be pushing or pulling all the time. Okay, magnetic force can add at the distance, correct? Okay, because it's a non-contact force. Okay, you doesn't need them to come into contact, doesn't need them to touching each other. An object experience balance force. When you balance force, you may either at rest or uniform motion. You won't change your speed. So this one is correct. Okay. 2A. Okay, tram moving at steady speed, fixed direction. Obviously, this is a balance force. Weight held at rest. Okay, again, at rest, balance force. Lift slowing down, that means decelerating, so that would be a unbalanced force. If we took a look of the lift, okay, so because it's slowing down, the force going up or down have to be larger. Slowing down, that means up have to be larger, down should be smaller. So therefore, we have a net force going up. Okay, so therefore the lift will not be spinning towards to the ground. It will slowing down, okay, when it's going down. So to summarize, okay, a free body diagram, you show all the forces adding on it. Remember, on an object, one object only. Second one will be a balanced force adding on an object. When you have a balanced force, you have two events. Okay, one, either it will be at rest. Two, it may be in uniform motion. Okay, if it is an unbalanced force, the object, the motion will change, the speed will change. When speed change, you may use the word accelerate or decelerate to help to describe. So at the beginning, we talk about the scrumming. Okay, scrum in rugby. So this one, if it is a balanced force, okay, at rest, but suddenly the red, okay, will become stronger. They got a unbalanced force right there. So what happened to the yellow one? It will then be start moving to the right, or accelerating towards the right. Okay, so that's all for this video. Bye bye.